we'll discuss power convention. The element, positive reference current and positive reference voltage. P is calculated as multiplication of the voltage and current. If P is positive, power is being absorbed. If P is negative, power is being delivered. We'll show it by an example. Find the power delivered or absorbed by each element in the given circuit. 10 volt. So we'll do one by one. So what is the current? I equal to 2 ampere. What is this voltage? V. Voltage V is equal to, using the KVL around loop, I'll traverse this way. So V equal to 10 minus 2.5 into I, which is 5 volt. So power for the voltage source. For voltage source, you see this is a positive terminal here, negative terminal here. So voltage V10, and current is opposite to the what is given in the convention. In the convention, current should flow at the positive terminal, but here opposite to the positive terminal. So what I will write? Minus I. So which is 10 minus 10 into 2, that is minus 20 watt. So it is negative sign, so delivered. Let us move to the resistor. P is equal to I magnitude square into R. So here the current is I is equal to 2, so 4 into 2.5 is the 10 watt. So resistor always absorb power. Then we'll move to the current source. P is equal to voltage and current. So voltage is the here V and current is the 2 ampere. So voltage V we have already calculated before here, that is 5. So 5 into 2, that is 10 watt. Again it is a positive, so absorbed. You see that power delivered is equal to the power absorbed. Power delivered is the 20 watt and power absorbed is the 10 plus 10, 20 watt. You will study later on that there is a theorem called the Telgen theorem, that is the sum of total power is 0 in a circuit. Next we will move to the circuit analysis. We have studied the KVL and KCL. There are two methods initially to solve the circuits. Later on you will study, after learning the network theorems, there are many ways to solve the circuit. Now let us concentrate on the two methods, that is the loop analysis and node analysis. First one, loop analysis. Second one is the node analysis. Loop analysis: if a network has n nodes and b number of branches, then number of independent equation to be solved is the b minus n plus 1. Application of KVL. For node analysis, number of independent equation to be solved is the n minus 1. Application of KCL. We'll see another two types of network I put in category of 3: super mesh or super node. Here we will apply both KVL and KCL. Once again, loop analysis: number of independent equation to be solved is equal to b minus n plus 1. Application of the KVL. Node analysis: number of independent equation to be solved is the n minus 1. Application of KCL. Super mesh or super node: application of both KVL and KCL. We'll go one by one. So here is the circuit. There is a independent source of 20 volt, another voltage source, that is dependent voltage source of 10 I0. I0 is the current flowing through the 6 ohm resistors. We need to find the value of I0 applying the loop analysis. So what we will do, first we will mark the loop current. I will designate as the I1, I will designate as the I2, and here I0 is flowing. I will keep it as a I0. So one by one write KVL for each loop. So loop 1, loop 1, loop 2 and loop 3. In the loop 1 I will traverse this way. So 2 into I1 minus I2, then plus 4 into I1 minus I0 is equal to 20. Rearrange this, you will get the 3 I1 minus I2 I0 equal to 10. Let it be equation 1. Go to the loop 2. You traverse this way. So minus 10 I0 plus 8 I2 minus I0. From this you will get minus 2 this is your equation 2. Then loop 3. In the loop 3 you will be traversing this way. So first one will come 6I0. So you have 6I0 plus 4I0 minus I1, this term 4I0 minus I1, then 8I0 minus I2, then plus 8I0 minus I2 equal to 0. From this you will have minus 4I1 minus 8I2, then plus 18I0 equal to 0, which will give you minus 2I1 minus 4I2 plus 9I0. Equation 3. So you have 3 equations. So you need to solve it for I0, and I will use the Cramer's rule. Cramer's rule tells that I0 is equal to D3 upon D. What is the D3? You know how to calculate the determinant. So it will come out minus 5. That is the main reason I say you should revise the calculus, algebra. The level of 11th 12th standard will be sufficient. We will do example of node analysis. So this is the circuit. We need to find the V. We'll apply the node analysis. So here is the V. So here is the one node. Here is the datum or reference node. Another node is here. So I'll designate as the V1. This current is coming here. So one current will go here. Another current will go here. So I'll write the equation for this node. 5 ampere is coming equal to V1 upon 2. This current V1 upon 2, and this current is the V1 minus V upon 4. So multiply 4 both the side. So 20 equal to 2V1 plus V1 minus V. So you get 3V1 minus, and it becomes your equation 1. Now for this node, the current, one current is going here, another current will be going here, another current going here. Only one inward current, I have marked the 3 outward current. So outward current will be the V minus V1 upon 4, this current, plus V upon 6 plus 5 is equal to inward current to the node 10. So multiply 12 both the side. So 3 into V minus V1, 2 into V 60, 120. So you will have minus 3 V1, 5 V equal to 60, equation 2. So you can easily solve, add both the equation together. It will give you 4V is equal to 80. Then we will discuss super mesh. Super mesh is one when two loops have a current source in common. Here is the example. Find this current I. We need to find this current I for this circuit. So first of all, I'll assume this current is I, and this current is going, because 6 amperes is coming, so I have applied a KCL here. So 6 I ampere is going this way. So how much current will be going through the 10 ohm resistor? That is 6 minus I. This is 4 ohm. Now apply KVL. 20, I am traversing this way, plus 6I minus 14, 6 minus I equal to 0. So divide by 2, 10 plus 3I, 10I is equal to 32, which implies I equal to 3.2 ampere. But what they have asked to find out? Capital I. Capital I is equal to negative of the small I, that is minus 3.2 ampere. Here we have applied KCL. Here we have applied KCL for this node and KVL around this loop. Next we will discuss super node. When a voltage source directly connected between the two nodes, excluding the reference node, we have a super node. Example. What is the value of V3? See here, the node V2 and V3 has a voltage source connected between them. So I'll write KVL for these two nodes. So V2 minus V3 equal to 4 volt. Then write KCL for this super node. So this is a super node. So current, this current comes, this current goes, this current comes, and this goes. So what is this current? 8 minus V2 upon 4. This current plus 8 minus V3 upon 4 is equal to this current plus this current, outgoing current, V2 by 2 plus V3 by 4. Multiply both the side with 4. So 8 minus V. Now solve equation 1 and equation 2 for the V3, because we require V3. So multiply the equation 1 with 3. So 3 V2 minus 3 V3 equal to 12. So subtract. So you will have 5 V3 is equal to 4. We'll discuss in the next video some of the gate questions coming from the basic network theory chapter.